Right, good evening, everyone. All right, today we want to look at our last leg with regards to the analytical question. So far, we have looked at two past exam papers, and we now want to complete this last leg in terms of analytical. Right, like I said, it's mechanical drawing, and there's question number 1, which is on analytical. So we want now to make sure that we fully understand this concept and we fully understand how to answer this particular question. But it's a very important part of paper 2, so do not take it for granted or do it as an afterthought. Make sure you're fully prepared to answer question 1 in terms of paper 2. Our content is basically mechanical drawing. That's the main thing, right? We are looking at analytical, which is part of paper 2, right? We are going to look at a revision exercise. It's a past exam paper, right? We also going to look at approaches and how we can apply that understanding in order to answer the question. As always, we need to make sure that we are able to link right, whatever we do with regards to this very good statement, right, which we take from Rotary, right, it's a very important and very encouraging and educating Chinese proverb. I hear and I forget, I see and I remember, I do and I understand. Like I said, always our thrust is to make sure that you are able to do on your own in order to show application and understanding of the concept that we are talking about or we are dealing with. So enjoy this lesson and thank you. Right, as always, we have got question 1 in terms of our discussion. Remember, this is our third leg in terms of our discussion on the analytical, and I'm sure you have benefited from the 2 exercises that we did for the last 2 days. Like I said, this will be the last. Then we move on to the assembly part in terms of paper 2. Right, given an assembly drawing showing 2 views of a gas regulator assembly, a parts list, a title block, a table of questions. The drawings have not been prepared to the indicated scale. Remember, we said that if the scale, the indicated scale, we have got a scale here, which is 1:1. If we were to look at the bottom here, you'd find that at the bottom, we have got 1:1. I shall show you that. Right, but it has not been prepared to that particular scale. So it is said to be not to scale, which is NTS. Right, so if we look at the bottom there, let me just show you. Right, we have got what we refer to as parts list, okay? Right, this is the list of the parts that have been used for this, right? And also we have got the title panel, right? This would give us information with regards to the manufacturers and what needed to be manufactured. So we have got the title block and also what we need to, just trying to make sure that you are able to see clearly. Right, okay. Now, we have got the title block and we have got the parts list. So the parts list would describe the components or the parts that have been used with regards to the assembly that we are looking at. And of course, you have got a set of questions which would start from question number 1 all the way, and you also given the space where you are going to respond to in terms of those questions, okay? Right, so the first question that has been asked is, right, what is the title of the drawing? Right, so what is critical here, right, is to make sure that you are able to look for this word title, okay? Right, you are able to find that word title, right, and the title, you would find that right under the title block, okay? Right, here it is, you have the word title, okay? So the title is a gas regulator. So you would go there in terms of your space, you write gas regulator, like that. Right, what is the web address? Right, we know about the web address. Right, here the keyword is web and that address, the website. So if we look under the title, you find that here there is the web address. Maybe you may not be able to see that one clearly. Right, but here, right, we would find the web address. It says www.theongas.co.za. So that's what you are going to write. www. .co.za. Right, so we have got www.theongas.co.za. Right, that is the information that you would require in terms of, right, in terms of getting to the website of the company. Right, the next thing that we want to look at is question number 3. What method of machining is prescribed? Right, what method of machining is prescribed? Right, so you look at machining, right? Again, you go to the title block, right? Here we have got the method of machining, right? All this information, if you check properly, it will be given to you, it will be provided either on the drawing itself or on the title panel or on the path list. Of course, here and there you'll find that you may need to apply the concept of engineering drawing or mechanical drawing in order to respond to the question. So we have got the method of machining, which is milling. Then you write here. Right, that's milling. Then the next one, which drawing program was used to prepare the drawing? Right, you look for the drawing program. The keyword there or keywords are drawing program, which are here. Right, so you also come and check. You'll find that the drawing program is given here, right, which says AutoCAD 2016. So you would write here, the way it has been written, you write AutoCAD 2016 like that. Then on what date was the drawing drawn or done? Right, so you are going to look at drawn, right? And Vikas is the one who did that in terms of the drawing, right? And on what date was this done? Right, it says 2015-10-31. So it was done on the 31st of October in 2015. Then, but you write the way it is given. So 2015-10-31, like that. Right, who approved the drawing? Again, you look for the keyword, right? The keyword there is approving, right? So we want to make sure that we look for that, and there it is in terms of approving, right? We see that it is on, right? Right, so you are going to write that S-O-O-N, right, soon. Right, what material is used to manufacture the seal? What material is used to manufacture the seal? Right, if you want that kind of information, right, you go to the pass list. Remember, the pass list would give you the description of a component, would also give you the quantity of that particular component and the material that it has to be manufactured from. So you look for seal, right? We have got the inlet seal, which is here, right? That's what we are looking for. Then number of, it's 1, and the material that has been used or that is going to be used for the manufacture of that particular part, it's a rubber. Then you write here. It's rubber like that. So what material is used to manufacture the seal? You get it from the parts list, then you write it nicely. It's rubber. Remember, we are looking at an actual exam paper. I think this is 2017, right? Which November 2017, which is very important because now we link, right, with the actual papers which are current, right? Remember, if you want to succeed, right, you need to look at papers not older than 5 years so that you look at the current trends, right? Don't go beyond 5 years. In most cases, you would be out of the trend. Right, what is view 1 called? Right, we have got this is our view 1, and we have got another view at the top. Right, remember, in paper 2, right, the principal system of projection that is used is third angle orthographic projection. Right, third angle orthographic projection dictates that what you see at the top here is drawn at the top. If you are looking from this, right, you'll be able to draw the top view at the top. Directly below the top view is the front view. But now this has been sectioned, so it's a full section of front view, right? It is a full section of front view because we have got everything sectioned from left to right. So we are going to write here full sectional, right? View, it's already there, so that would suffice if you simply state full sectional front, right? So that is the view, right? Remember the view that you see just below, if there are 2 views, right, one on top of each other, and you see these in paper 2, automatically you know that the one at the top is the top view, and the one below is the front view. 2 views side by side. One could be the front view, and the other one either a view or a right view. So that also needs to be taken into consideration in terms of understanding this. Right, name the feature at A. Name the feature at A. Right, we have got this. Right, remember in engineering drawing, right, we also need to familiarize ourselves with features which are linked to machine drawing. Right, so if we have got something like this, right, you have got a component like this, right, and you have got another part, maybe they are joined like this, right. Now, you'll find that you can remove this sharp edge, right? And also remove that one like that, right? Maybe to improve the aesthetics or for safety purposes, you want to make sure that it is safer to handle and so forth. So you don't want sharp edges like that. Now, this is what we refer to as a round, right? So if we do it on the outside like this, it is referred to as a round, right? Then if you also want to strengthen this joint, right, you'd find that we can also create, normally you'd find the centers like that, and we do this like that, okay? Right, when it is kept inward like this, right, it's no longer a round, it's now called a fillet, right? So get to know about these things, they are important. Yesterday, we talked about the issue of the web, and when it is a web, normally you'd find that it will be shown like that, okay? So then you have got a web, we have got a round, we have got a fillet like that. So let's go back to our question, right? In terms of this part, right? So according to the sketch which I illustrated, right? According to the sketch which I illustrated, this part, therefore, it is a round. Presentation of work is critical. Make sure you write in such a way that someone would be able to see. All right, do not scribble, right? In most cases, what is preferable is to make sure that you use capital letters or the uppercase. So round, so that no one would mistake anything for anything, right? In terms of legibility of your handwriting. So you write in capital letters like that. Now, number 10 is now about the determination of the dimensions at B, at C, and at D. Right, if we look at this, right, let's go to B, right? What is critical is to look for B, right? B, we find it here, right? That's our B, right? Let's bring it closer, right? That's our B. Now, we are told that the distance from here to there, that's our M22, right? M22, which is metric size 22, right? And M22, 22 is a diameter, right? It's a diameter, which is diameter 22 like that. So if you have got M22, you can also do this like that, whereby you can draw a circle like this, right? If it is an external thread, you'd find that this will be a complete and outlined, right? An outlined circle like that, right? Now, you would also need to find the threads, okay? The thread depth, we talked about that at some point, right? The thread depth, if you are not given, let's check, right? In this way, are we given that thread depth? Right, we are not given, right? We don't have that information here. So what it means is that if you are not given the thread depth, remember the distance from here to there, it's the outside diameter, which is the outside diameter. We can all refer to this one also as the nominal, right? The nominal diameter, or it can also be referred to as the outside diameter in terms of a thread, okay? But if you are not given the depth of the thread, you would say 0.1 multiplied by the metric size, which can also be referred to as D like that. Right, then we would say 0.1 multiplied by 22, but would get 2.2. which is equal to, right, let's 0.1 multiplied by 22 would end up getting 2.2. Right, so what it means basically is that the distance from here to there is 2.2. The distance from here to there is also 2.2. Right, then you would measure from here to there, then you draw an incomplete, you leave a small little gap like that. The distance from here to there, that's 2.2. The distance from here to there, that's 2.2. So the inside diameter now is from here to there, which would be 22 minus 2.2 multiplied by 2, because they are 2. What you'd get is 4.4. Then you would say minus 22 minus 4.4, you get 17.6. So the distance from here to there, right, is 2.2, 2.2, all being subtracted from 22. Then the answer that we require is 17.6. So you come here and write 17.6 like that. Right, so these are some of the things that you need to know, right, in order to answer the question 1 in terms of paper 2. All right. Then C, let's look for C. Right, C is here, right? Right, so we need the length from here to there. Right, that length from this part to that part, which is the full length. Right, what we are given is that information from here to there, that's 45, and we are also given 40, we are also given 30. Right, then you are given here, right, remember we talked about this, we have got a part like that, right? Maybe you provide the center line, right? Then you have got 5 millimeters, you chamfer like that. If the distance from here to there is 5 millimeters, and if we use 45 degrees, the distance also from here to there would be 5 millimeters, okay? Like that. So once you are given the distance, right, which is from here to there, right, like that, is 5 millimeters, automatically the distance also from here to there would be equal to 5. This is significant in the sense that you are given 5 by 5. So the distance from here to there is 5, the distance from here to there is also 5 millimeters. So what we have between here, we are going to say we have got 5, and also here we also have got what? 5. Right, so 45 plus 5 plus 40 plus 5 plus 30, that would give us the total length, which is C. So it's 45 plus 10, the 2 5s, plus 40 plus 30. Right, we end up getting 125. Right, that's 125. So from here to there, that's 5. From here to there, that's 5 as well. So we needed that measurement, okay? Right, let me just confirm again. We have got 45 plus 5 plus 40 plus 35. Right, we get 125. So we are going to write here 125. That is the distance from here to there, right? Which we would get from the other view. So like I explained for the past 2 days, right, you need to make sure that you check the information that you want may not necessarily be on the view that has been directed. You can relate it to the other view, like here. the information in terms of the question that has been asked is on the top view, but the answer is found on the front view in terms of the sectional front view. Right, D, right, let's look, where do we find D? D is here, right, this is our D. We have got the distance from here to there, right, to that part. Right, but D would take us to this part here, which is, right, if we check, right, we can find that information maybe at the top, right? You'd find that here, right, from this part, from this point, all the way down there, we have got 25, 20, not 25, 23, plus 22, plus 25, plus, right? So what we need now is to say, if we want the distance from here to there, to the center line of this, but this one is said to be M10, right? And if we check even with our T-square, you find that that's the distance from, it's going to get us to that, right? So the distance from here to there, if this is M10, which means from here to there, that's 5 millimeters, okay? Right, remember, M10, when they say M10, 10 is a diameter, right? So to get to the center line, we need 5 millimeters, right? It's not here, it's right there in line with the M10. So 5 millimeters plus all that should give us something. So we'll say plus 5, right? And the height that we require all the way from the top to that would now be equal to 75. 23 plus 22 plus 25 plus 5. Right, 23 plus 22 plus 25 plus 5, but you would get 75. So you would write here nicely, that's 75 like that. Right, I hope you are following what we are doing so that you will be able to do it on your own in an exam setup. Right, measure the angle at E, right? At some point we were given a scenario like this, right? Where we were supposed to measure an angle like that. Like I said that day, right? You need to extend this, just extend this, like that. Then also extend this one. Once you have done that, you can bring your protractor, but you are now able to align. There you go. Right. So if this is our point 0, which is there, so we've got 10, 20, 30, 40, 50, 60, 70, and it's in line with 75. Right. So you align with that line that we have created, that we have extended, right? Then you count from there, you have got the number of degrees that you require. Right. So according to my measurement, right, the angle there is 75 degrees. Right, why is the part at F filled in solid? Right, we have got F, so the important thing is to identify that F, right, just like we identified E. Whenever you have been asked a question, look at where you are able to find that particular relation in terms of the link to the question and the asked part as well, right? So in this case, you have got F, right? We have got that. Now, you'd find that in most cases, right, if it is something to do with sealing, right, that could be rubber, but at some point as well, right, if it is just placed anywhere without element of sealing, right, you'd find that that may relate to a thin material which cannot be shown by normal hatching techniques. But in this case, right, we have got a gas regulator. So what the assumption is that this is rubber, since it is supposed to provide some kind of a seal, right? And you can even see that one, number 3, right? It says inlet, okay? Inlet rubber. So if you see black, right, on a pump, on a machine, on a drawing, in a mechanical drawing, black like that, you know that it is representing rubber, okay? Like I said, also, you would find that you can also have that thinnish material, right, representing a thin material, which cannot be hatched by normal hatching processes, or which we cannot show the actual size, right? Then we represent it by a thin line. But in this case, that is a seal, which is an inlet seal. That's a rubber. So we write here. That's a rubber. Right, what is indicated by the feature at G? So the important part is to look for G, which is here. Right, G is representing a section. What section are we looking at? Right, remember, if you have got information, right, which would normally not be shown in hatching, like a shaft, but if there is certain detail that you would want, right, which is inserted into a shaft, say you have got a key which is inserted, so that you expose the detail which is inside, and we refer to that part of section or that kind of section as party section. Okay, so that is part section. Right, it can also be referred to as a scrape section or local section. Right, you find that different literature books would provide you with a different term, but the one which is commonly used is party section, like that. Name the type of finish at H. So we need to look for H. Right, so here it is, that's our H. At some point, I spoke about the 2 main forms of finish, which is associated with H. Right, when you see something like this, right, what it means, what would come quickly to your mind is the issue of grip. If it is a turning component, you want to not it slipping in your hands, and that kind of finish is referred to as nailing, right, like this. Right, so there are 2 kinds. We have got straight nailing, we have got diamond nailing, and the principal application of that finish is to make sure that you are able to handle something with more grip. Refer to the parts list and identify the part at J. Right, so the issue is to look at, right, at J, okay? To look at J, right, we will see that this is closing everything, right? Right, this part is closing everything, right? And in most cases, when you want to close everything, we refer to that one as a cap, right? So it's capping, it's covering everything. So that part 8 At J, that's a cap. Like that. Right, how many surfaces of the gas regulator assembly must be machined? Right, yesterday we talked a bit about machining symbol, right, and how it is represented and the information that is associated with the machining symbol, okay? The types of machining methods that are applicable and the data or information that is associated with a machining symbol. As homework to you right now, I want you to look at the machining symbol from your textbook, get to know all the applications which are related to a machining symbol so that you can answer any question which is posed to you concerning a machining symbol. And I also talked about a welding symbol. Make sure that you also get to know the elements of a welding symbol. That kind of question can also be part of question 1 in paper 2. So I just want you to be prepared for the exam. Right, now if we are looking at a welding symbol, this is a typical one. So we have got 1. Right, the question would be, how many surfaces of the gas regulator assembly must be machined? So we've got 1, we've got 2, we've got 3. Right? Now, if you check, right, with regards to this, we have got 1, 2, and 3. Right, this surface here is the same as that. Right, but that cap has got how many signs? It has got 1, 2, 3, 4, 5, and 6. So 1, 2, 3. Right, so there is a machining symbol. Right, there is another one here. There is also another one there. If this surface is machined, the understanding is that this also, that also, and this one, and that one, and that one, they all need to be machined as well. So we've got 1, 2, 3, 4, 5, 6, 7, and 8. Right. 1, 2, 3. Right. This one is already defined. So we have got plus 5 more, which is 3 plus 5 will get 8. So we write here 8. So sometimes you need to think outside the box and look at the bigger picture in terms of the question that has been posed so that you come up with the correct answer. Do right? Look if they are any similar, right, surfaces which maybe we can see on the top view or somewhere else. Like yesterday, we talked about information that was given on 1 lakh. That they were 3 lakhs. So we needed to apply that knowledge of the 3 in order to come up with the total distance. Right, why is the feature at K tapered to one side like that? Right, it's here, okay? Right, it's tapered in one side. In most cases, you'd find that when you have got an application like this in terms of an engineering component or a part, right, you want to make sure that the movement, right, is basically one way, and when it tries to come back, right, it is held by that. You can force it in, right, and in most cases you find that it will be forced into rubber or something like that. Right, to pull it back, you need extra effort. So the reason could be that you want to keep, right, that item in position, right? You want to avoid slipping out, right, which is now stopped by that, okay? Right, so the answer that we can give here, to keep in position. All right, you can also state that to allow one-way movement, right? So that the movement backwards, it's not so easy, it's restricted, okay? All right. Here, you can express yourself in terms of the response because, right, the answer is not given here. It needs your judgment. It needs your understanding of how that part can operate. Right, insert a cutting plane on view 2 and label it SS. Right, remember when we are looking at a cutting plane, right, and how many marks are given there? 3 marks. But when we are looking at a cutting plane, right, a cutting plane is basically a center line like this. Then you find that it has got thick ends, right, and those thick ends, they are not touching the center line. Then associated with that, you now have got the arrow. Like that. Right. Normally you'd find also you have got a letter which is associated. It could be any letter of the alphabet. Right. What is critical is to note that from a cutting plane, we should be able to get 3 kinds of information, right? We need to know the position of cutting. Right, the position of cutting is defined by that. Right, and we also need to know the direction. Right, the direction of looking at the remainder of that which has been what? Which has been cut. Then we also need to know the name. Now, you'd find a view, but you should be able, or an object which is represented by a view, you should be able to say, this is section AA, right? Section AA is basically coming from here. So this is what we refer to as the name of the is when you are able to see the remainder of that has been cut. Where the tail is coming from, that's where you are throwing away everything. So you have got the part that has been cut, right? And you throw away, right? Which everything that is on the tail side. Remember, this is basically theoretical. You are not going to physically cut. You are not going to physically throw away anything, right? It has to be imagined that if an object has been cut, what would you be able to see? That is the function of a cutting plane. So it gives us the position, it gives us the direction, and it gives us the name. Right, so in this case, we are given that information, right? We are supposed to label it SS. So what I'm going to do, right? I'm going to position my cutting plane here. Remember, this is the resultant of the cutting plane, having cut the top view, right? What we know, right, in third angle orthographic projection, right, for you to be able to see this, you need to expose something. So the first thing that we need to look at, we just use a different, can come here, thick end, remember what I said? That's a thick end like that. Then we do this, right? If it's not so clear, we can use show by way of an arrowhead proper. Sometimes it would be enough for you to just thicken one end, thicken on one end. So what it means, this is the position of cutting, which would result in us being able to see this section of front view, and that is the direction. So if you change the direction and you are looking from this side, right, the resultant view is that you are not going to be able to see the part that has been cut. So the direction is critical, the position is critical, and the name, right? So that we will be able to identify, right? So that we'll be able to identify that particular cutting plane. So it's going to be cut along this line, right? We are going to view from this direction, and the name, right? Sorry about this. It is supposed to be, right? It's supposed to be S like that, right? I'm linking to our earlier discussion with regards to the explanations that I was making, right? So you have got SS, right? You find that in marking, we mark the position, the arrow, and the name. The same applies this side, right? It's also marked the position, the arrow, and the name, which is 6 points that you would gain. 6 divided by 2, because it's a half a mark, you will end up getting 3 marks like that. Right. So that is shown and illustrated with regards to the position of the cutting plane. Now, in the space below, let me take this one. Right, in the space below, right, in the space below, answer 19, draw in neat freehand the convention of a coil ring. Right, they talk about a convention of a coil ring. Right, remember this coil ring, in terms of rings, we did that under helix, right, where we were able to draw the coil ring, the square spring, right? Not ring, the spring, the coil spring, as well as the coil spring as well. So it was the square and the coil, right? Now, if you are looking at this, you have got, maybe that's our center line, right? Like that, right? You'll find that there are 2 types, right? I'm going to do this, maybe create a line like this. You have got this, you have got that, you have got this, you have got that, you have got this. And you have got that. Now we can also define this one. Right, like this. And this one facing different direction, but of course same size like that. Then you would need a center line like this. Right, in most cases, if it's represented like this, you know that it is, right, a compression coil spring, okay? Right, but if you find that it is like this, right, and this other one would turn like that, right? What it means is that this would be tension or tensile coil spring, right? It would counter the effect of pulling. The first one, if it is like that, it would counter the effect of pushing, okay? Right, so it's compression, right, with this one, right? When it is like that, it is tension, okay? Right, but for this one, we'll just make an assumption that maybe what is required is a compressional one, right? So we are going to draw a straight line like that. This is the convention of a spring, right? And this end and that end, they should face different what? Different direction for it to be correct. And also you provide a center line like that. So I'm going to sketch, right? They say in freehand, it's either you can do it this way or you can do it like that. So I'm going to do this friendly face, but create 2 lines and 2 lines like that. Right. I need the start. Right. Then you have got that. Then you also have got this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you take it like that. Okay, then I can outline this. Remember, you should not spend more than 30 minutes or even 20 minutes on this particular question, okay? So that you give other questions good enough attention time. So that is our center line. But normally you'd find that you'll be marked for this, and that one could be a complete mark, but we have got 3 marks there. You also have got this, right? So 1, 2, 3, 4, right? And also the center line, it could be another one, then the free hand, right? So the convention in terms of how to represent a string, right? And also that end and that end. Right. Then in the space below, draw in freehand drawing, right? The symbol for the projection system use, right? You don't even need to struggle with regards to this, right? We know that the work that is done here, okay? The work that is done here in terms of the 2 views which are shown, right? This is our top view, this is our front view, and whatever you find in paper 2 in terms of system used, right, is done in third angle orthographic projection, right? So what you need to know is how that symbol in terms of third angle orthographic projection is done, right? Remember, what you see from the left, but what you see from the left is drawn on the what? On the left like that. Right. What you see from the left is drawn on the left. What you see from the right in third angle orthographic projection is drawn on the right. So this is a truncated cone, right? Like that. You need center lines like this. You also need a vertical center line like that. Right, so this part which has been cut, when you are looking from the left-hand side, is the one that is drawn here. Right, this is the base. Right, when you are looking from the base, you look at that, you take it back, and you draw that one like that. So this is a typical third angle system symbol in terms of system of projection. So we'll take this one, you bring it here, right? Projection symbol, we always start friendly like that. This line and that and that. Right. Then you draw 2 concentric circles like that. It's freehand, okay? Then you take this one there, you take this one there, take this one there, take this one. You connect there, connect like that. But the next thing, you may want to outline. Remember, when you outline, you correct even the small little mistakes that you were making. Center line like that. Then also another center line like that. Right. You have got 1, 2, 3, 4, 5, 6, 7. The 8th one is the freehand, right? You'll be added another mark for drawing this in freehand. Right, so we have got the projection symbol like that. Right, I hope you liked the lesson today and you enjoyed it as much as I did. Right, so this is it in terms of our paper 2, question 1. Right, we are now going to move away from analytical. We look at another question with regards to paper 2. right? So that we touch everything. I think we touched everything with regards to paper 1. Now we are on paper 2, right? So we have got this. In terms of our projection symbol, we have got the spring, right, as asked, right? Okay. So when we meet tomorrow, we may now be looking at how to start with regards to assembly drawing. Thank you and good night.